Hello, I'm going to go ahead and get started. Oh, those are back on. If you don't know me, I'm David Scarborough from Endocrinology, and this is a topic that's close to my fat boy's heart, and so I have a tendency to put in a little too much. I hope I haven't done that today, although I probably have, but hence I need to get rolling here. Nothing to disclose. So the topics for today is to just go over a little bit of obesity basics. Most of you are going to be familiar with this anyway. And go on to a little bit of the underpinnings of what we understand about the nature of the obesity issue that we face in the country, the treatment options that are the commonly considered ones, and then leaving some time to go over some newer points of view on how we ought to proceed individually and as a profession at dealing with this. So BMI, I think we know, is kilograms per meter squared, and it's a shorthand for fatness, basically. And these are the conventional categories: underweight, which we all know from billing cachexia on inpatients and so forth, and then normals, overweight, obese, and different categories of obese. So occasionally you'll find people that have high BMIs, like here's 42, here's 56. This is a professional football player and a sumo grand champion. However, these are unusual individuals, and they tend to be athletically healthy only while they're working out like crazy, and that's unusual. Now, the reason that we applied unhealthiness to different levels of BMI is because of data like this. And you can see here at a BMI of 25 is about where you begin to get an uptick in mortality in men in, well, cardiovascular disease, cancers, which you wouldn't necessarily think of that right off the bat, and then all kinds of death apparently can kick up above a BMI of 30. So this is overweight, and this is obese, and on it goes. This is a slide I keep adding to. It's all of the associated unhealthy things that can hit you if you are obese. And I'm not going to go through the whole array. And here again, most of you are familiar with most of them. But some of them have been added more lately. For example, fatty liver disease. But there are even more things that you can put down on the trailing list. And I did want to highlight social discrimination, and in particular from healthcare providers. And all of that contributes to poor self-esteem by patients and also impairs healthcare. So here's a CDC MMWR from October 2017, where they're pointing out that looking at cancer statistics, they found that there was an association with a whole long list of cancers, including thyroid and endometrium and colon and breast and esophagus, and that when they summed it all up, they found that about 40% of all new cancer diagnoses were in some way or other associated with an increased risk because of obesity. Now, here's another one that's just one among many. You could find slides like this for everything that was on that prior slide. And this was a study where they were just doing sleep studies. And they happened to weigh people at each visit. And if between visits they discovered that they had gained, they also tended to find that their sleep had worsened. And if they happened to have lost, their sleep tended to have gotten better. And we know that sleep apnea is not good for you in all kinds of ways. So, here we are, sleep, and overweight. We've all of us, I think, seen these slides before. This is one where over time you see how things are getting worse in terms of obesity within the United States. And then here you see that trailing a bit behind is diabetes. And unfortunately, this is largely continuing, meaning that as the population gets more overweight, we're going to see more morbidity and mortality. And the problem there is there's so much overweight that I don't know how in heaven's name we're going to be able to afford the type of health care we like to deliver to the folks suffering all the morbidities that they're going to be suffering. So here's some recent CDC data in terms of self-report of obesity. And the point of this is we're still fat central here in Louisiana and the Deep South. And then here's another CDC website where they're talking, and this is the same time as the former one about cancers, October 2017, where they say, what is healthy weight loss? They say that gradual and steady would be best. And it isn't just about a diet or a program, it's about ongoing lifestyle for long-term changes. And then they go on to say, to lose weight, you must use up more calories than you take in. So it's basically just a subtraction problem. And 1 pound equals 3,500 calories. Therefore, you need to cut your calories by 500 to 1,000 to lose 1 to 2 pounds per week. This is such a massively outdated and inaccurate concept. It's amazing to me it's still on a CDC website because, in fact, all kinds of adaptations happen. This kind of thing works for like the first week and a half or something, and after that it starts to become inaccurate. Then it says, once you've achieved a healthy weight, by relying on healthy eating, which is less eating, and physical activity, which is moving around more on most days of the week, you are more likely to be successful. So if we sum that up, we would say they want you to eat less and move more, which again makes it sort of an arithmetic problem. And I have put here OMG because, as you'll see, this is quite the oversimplification. Now, just in case you haven't seen in a while the 7 deadly sins, here they are. Here's the you need to move more deadly sin of sloth, and here's the you need to eat less deadly sin of gluttony. Now, here in America right now, we're not suffering any shortage of the other deadly sins. We have plenty of pride, envy, greed, anger going on in our national discourse. I'm amazed how many times the online news uses the word so-and-so blasted so-and-so or so-and-so slammed so-and-so. What about disagreed with so-and-so? I guess it's not good enough clickbait, is it? Anyway, so this is Ed Astwood, or Ted to his friends, who founded the endocrine section where I did my fellowship. And he was president of the Endocrine Society in 1962 and actually gave his presidential address on overweight and obesity. And he commented that obesity was a disorder like venereal disease that's blamed on the patient. This would be the people with sloth and gluttony, I believe, is who he's talking about. And he says it's regarded along with narcotic addiction as something wicked. He, on the other hand, goes on to argue in his talk that there was rather more physiology and genetics involved than turpitude, let's call it. So, studies have been done, and healthcare providers, including physicians, self-report that they often view the obese patient as someone who is non-compliant, dishonest, as in lying about their intake, lazy, as in, oh, well, you know, slothful, lacking in self-control, gluttonous, weak-willed, unintelligent, unsuccessful. And they often think if these people would just eat less and move more, then I wouldn't have to be nagging them when they come into the clinic every time. So here's somebody, this is Oprah. Here's Oprah when she had a bunch of weight off, and she's got a prop showing how much weight she'd lost in a American Flyer wagon. And here she is when she's got the weight on. So now, let's see, is Oprah any of these things? Well, her net worth is around $3.5 billion, so you can judge for yourself how unsuccessful she's been. Now, here we have some professional golfers, father and son, Craig Stadler and Kevin Stadler. So is this like nature or nurture? What is this? Is this the Stadler household just likes to set a heavy table? Or is this got some genetics to it? It could be either or both. So here's a classic study that was done with twins, either monozygotic or dizygotic, and reared apart or together. How excellent. So here are the monozygotics, and if they're reared together, their intra-pair correlation for BMI is 0.74. And if they're reared apart, it's still 0.7. Well, so much for environment. Dizygotic, look at the difference. And this is women. The pattern is quite similar, although a bit different. So, there is an environmental effect, but the genetic effect is remarkably strong. Okay, what about the environment? So here's a change in the environment over the years. This is a dinner plate that was purchased by my wife for our household in about 2000. And this is one of the dinner plates that I inherited from my North Georgia grandmother. She would have bought these sometime in the 1950s. They're what I remember from my childhood. You can get plates this size now, but they're called lunch plates, not dinner plates. So we have moved towards the bigger plate. Here's something else that I remember. TV came in when I was a kiddo. It was black and white originally, as I recall. And that's also where I saw commercials with various cartoon characters for sugar-sweetened breakfast cereals. Here's Sugar Bear. You bet your booties, Granny, he used to say. And Tony the Tiger. Sugar Frosted Flakes. They're great. And here's Cuckoo for Cocoa Puffs. So all of this. Now, what's in the whole grain Cocoa Puffs? Whole grain corn. What? Sugar, cornmeal, corn syrup, and so on. So this is sugared cereal. And this is what you might call big food if you're talking about corporate entities. And notice I didn't discriminate. I have General Mills, I have Post, and I have Kellogg's. So, all right. Now, other things going on over the period of time in which our obesity stuff has been getting worse and worse is the use of high fructose corn syrup, which went from essentially nothing to remarkably high levels. This is from Dr. Bray, who was the founding medical director of the Pennington down in Baton Rouge. Also did his endocrine training at Tufts in the same labs and building that were still there when I was there. Other things, however, have been going on over the same period. Households with computers have been going up, more and more use of cars for getting about. Here's the adult obesity and the adolescent obesity. And then calories per day appears to have gone up. It's hard to get these data, and these have been re-examined by various people. Probably some of the best modeling has been done by Kevin Hall, who's at the NIH, and he concludes that we are producing more food, buying more food, eating more food, and also wasting more of our food. So this is data that you get if you go through the public dumps to see how much food is there. And the answer is we're throwing away ever more, even as we're eating more and have more available. Okay, so why are we gaining so much weight? And there are a lot of things. We just discussed some of this. A lot more eating out, bigger portion sizes on bigger plates, more fat in the diet, but also more higher refined carbs in the diet, eating less fiber. We get less sleep. We have a zillion channels and so forth. We have cars and other things instead of feet and bicycles and so forth. We have a lot of physiologic causes of obesity, lots of them, and then there are a lot of drug-induced examples, all of which are in common use and commonly can contribute. And they didn't put insulin on here, and I don't know why, because it's one of the more reliable ways to put weight on people is to give them more insulin. So, in terms of physiology, hypothalamus in obesity. This has been known for a long time. Here's a netogram showing that if you lesion the ventromedial nucleus bilaterally, you'll get a nasty and very fat animal. This can be a cat or a rat or anything. And if you lesion the lateral hypothalamic area bilaterally, you can get an anorectic animal. So here are VMN animals. I had to do some experiments with some of these guys. You want to talk about nasty? They shriek, they squirm, they're big, they're heavy, and they bite. One bit me right through 2 leather gloves. Okay, now what's going on? Well, it turns out you can pair feed VMNs and they'll still have hyperinsulinemia and obesity if you pair feed them with controls. So let's see. This I thought was just an arithmetic problem. It was a question of intake versus activity. Now, these are animals that are in little rat cages. Not a lot of increased activity going on there. And on the other hand, what the intake is that of a pair-fed lean control animal. So, apparently it's more complicated. Well, we do know more now about what's going on in the hypothalamus than at the time the netograms were drawn. And this is just some of the pharmacology of the neurons involved in weight regulation. Here's the suprachiasmatic nucleus, which is our master clock location for light-sensitive circadian rhythms, and it does have inputs into the feeding regulation. So, zipping on to treatment. So, there's a big genetic component, true enough. On the other hand, the environment does matter, and our habits of life do matter. So if we're going to try to do things, we're going to try to do them on the environment or on our habits. And so we have diet and exercise. We can try to influence both physiology and behavior with drugs. And you can do surgery. And then we can do what I will call something old, now new again. So Oprah, God bless her, is still in there pitching. This is current websites for Weight Watchers. They have a program called Freestyle, not a diet, a way of living. So we see the same themes. Now, I don't want to get too catty about this, but you might want to say maybe there's more work to do. Yeah, that was bad. I apologize. And, just goes to show you, even somebody, can Oprah afford workout people and a home gym? I think so. Can she afford her own chef? Yeah, no problem. Guess what? Still not so easy. That's the take-home message. Okay, so this is conventional guidelines put together by the American Heart Association, the American College of Cardiology, the Obesity Society, and the list goes on. These are all well-known people. Well, I'm not going to go through them, but trust me, these are well-known people who know what they're doing, and so they've put together the guidelines. And here are a few highlights in which they say that if someone's got obesity, you ought to refer them to a high-intensity, comprehensive lifestyle intervention with lots of intrapersonal sessions, like 14 and 6 months, comprehensive, both individual and group, and you're going to put an emphasis on what? Eating less and moving more. Okay, that's original. Okay, now it says if you do this, you'll produce on the average a weight loss of 8 kilograms. And this is about 5 to 10% of initial weight. And the observed weight loss will vary person to person, so you can't accurately predict. And after about 6 months, they will equilibrate. And I say down here, what a bland word for such an important thing. What that means is, if you want to continue to lose, now your choice is, let's see, eat even less and move even more. Well, that'll work well. Will it? Okay. So, then it says here, we need to set realistic goals. And they point out that if you lose even 3 to 5%, you'll get meaningful changes. As for example, on the sleep apnea slide I showed you at the beginning. But they're going to recommend an initial goal of 5 to 10% within 6 months, because that's what current programs of Eat Less and Move More kind of tend to do. And they're talking about an energy deficit of 500 calories a day. Oh, well, we heard that before on the CDC website. They talk about specialized diets. And so here we are. Prescribe a 500 to a 750 calorie energy deficit, and they will let you use any diet that will achieve that. This is actually a relatively recent admission. They used to say it had to be low fat, and now you can do other things. Okay, now weight loss maintenance. Here's the bugaboo. It says obesity is a chronic condition over a lifetime, and they go on to blame the environment for that. Fair enough. I don't think it was genetic drift. It says the usual pattern is that maximum weight loss is achieved at 6 months, followed by plateau and gradual regain, including for using meds as well. Bariatric surgery patients maybe are going to do better, and they do tend to do better. And so strategies for weight maintenance. So, well, they basically think you ought to extend the comprehensive intervention and that you ought to up the activity prescription. Right. Eat even less, move even more. Okay. Okay, so now here's an old study by a well-known behavioral treater of obesity. And they did a 6 months treatment, either a very low-calorie diet, by which they meant less than 800, behavior mod, very well done by some of the very best people at it, and you could do combined. And this is what they observed. They were able to get off a little over, on the average, 15 kilograms. This is pretty good because it's north of 30 pounds. This is quite a bit. But look what happens at the regain. And this is just routinely observed and is one of the most disappointing things. Now here's somebody. This somebody is me. This is what my weight did when I was in my 20s, between 1970 and 1979. And life happens. And I've given a few things that happened. This is when I went back to college. I had gotten ready by slimming down, and then I got there and I gained. Then I got re-inspired when I read the aerobics book, and I was running and calorie counting, and I lost a lot of weight until I got stress fractures in both forefeet and had to quit that stuff. And then I regained until I graduated. And then it took me about a year to get into med school, and during that time I also got married, wanted to look good in my wedding suit. And so between running and dieting, I lost down some, and then I went back up. So that's that decade. And then the same thing happened, I will point out, in the decade prior. Since I started working on losing weight in middle school, I had gained it first in elementary school, and then continuing on in each subsequent decade until the present one. All right, so is it just me? Well, no, of course. Here's the diabetes prevention program, where we see the x-axis in years and we have change in weight in kilograms. We have lifestyle. They get off this weight over what? 6 months, and then it gradually comes back up. You can do metformin, doesn't work quite as well, but then they come together. And, here's the placebo group. And they're sort of at the same place after a sufficiently long period of time, as in 5 or 7 years. Well, that's a bummer. Now, does this do people some good? For a while, yeah. Puts off the diagnosis of diabetes for a while. So that has some value. It's just a little disappointing. So here's a meta-analysis of different approaches and what kind of things you get. So here's a very low energy diet, and you lose 6 months, and then here's the regain, the typical pattern, time after time. Here's exercise alone, and this just makes the point that unless you're doing Biggest Loser, exercise is not a great weight loss thing. It helps to maintain weight loss better than it helps to cause weight loss. Here's diet alone, which does better, but that too begins to come back. This is 4 years, so 5 years and so on is going to be farther out. And what else do we have here? Oh, here's meal replacements, otherwise known as shakes and bars, and it has a place. It works about as well as some other things. And of course, maybe you can make a little money in the office if you surcharge. Okay, here's a study undertaken specifically to look at weight loss maintenance. And here we have the first 6 months. This is the treatment phase. So they lose, and then they're starting to regain. This should be familiar by now, I think. And here we are doing all kinds of things to try to get weight maintenance. And let's see, this is, we have PC is active continued interventions. So that works a little better, although the error bars do overlap some versus the standard approach. So, alas. So why is this so hard? And a lot of suggestions have been made. One is that once you gain weight up to a certain level, you have a set point. It's like a ratchet. You can't go back. And that this happens for a variety of reasons in a variety of ways. We do note that if you're lean and healthy and we force feed you, you'll dump that weight in a hurry. Or if we short-term fast you, you'll regain the weight in a hurry. That, however, is not who is the problem. It's the people who don't self-regulate sort of automatically that are the problem. And unfortunately, that's most of us. So, slowing weight loss, and in other words, a plateau and weight regain. These are some of the reasons why it can happen. We have less tissue. We're eating less food, so there's less thermic effect of food. You can end up being less active, particularly if you're quite restricted. Your resting metabolic rate will go down some, and there are ways that this happens. And also, you get bored and fatigued with whatever you're doing. And in particular, if you're plateaued, you're disillusioned, and so you just drift off. And the aforementioned Kevin Hall, who's also on this thing here, believes that the regain is pretty much about, well, you start eating more and moving less. So, and he may well be right. He's pretty mathematical. Is there anything else, though? So now, quickly to drugs. Here's a Time magazine cover from 1996, a year in which 18 million prescriptions were written for the brand new weight loss drug. And it says here, the hot new diet pill. Redux really seems to work, but is it too good to be true? And the answer was, alas, yes, because there was cardiovascular morbidity. So there are a lot of other drugs over time that have been tried for overweight and discarded, going all the way back to thyroid hormone. Guess what? People still get given thyroid hormone. The state board does frown upon this, I will just point out, in case you're inclined to do that. And there's a guy that lost his license in Florida for doing that. Poison the electron transport chain, well, that'll work, but there's a kind of narrow therapeutic window there. Amphetamines, adrenergic agonists, cannabinoid antagonists, there was a downside there. It was called suicidality. And this is just your typical adrenergic thing. So those are all gone. Here's a nice review article of long-term drug treatment, and I'm not going to go through it. These things are all sort of flavors of what you've already seen to varying degrees. I've added a few more down at the bottom. So we do have drugs to choose from, but they are for the most part kind of adjunctive. And you know, they're worth using often, but they're not the big story and they're not the big cure. Okay, surgery and other invasive things. Bariatric surgery, there are guidelines for when it's appropriate. Basically, if your BMI is north of 40, then you're a candidate, and you're a candidate if your BMI is over 35 and you have morbidities related to that. Everybody is supposed to have tried diet and exercise. So there's the adjustable band. I think we're aware of what that is. Here's a vertical sleeve gastrectomy. This works fairly well. You take out most of the stomach. And here's Roux-en-Y gastric bypass, an oldie but a goodie. And do these things work? Yes, indeed. Here are the control patients who are not losing. Are they at a set point? Is this defended in some way? Okay. Well, here is the surgery. Now we're talking about losing 20% or 30% of body weight. Banding, less punchy than, say, vertical banded gastroplasty. And then the bypass is more punchy still. The error bars are big here. And so some people are doing less well, and other people are doing even better than this. And the time frame is even longer. So this is why it's such a popular notion and why it's being done more and more. And a couple of weeks ago, we had an obesity issue of JAMA, and it was almost all about the surgeries. And there was like two little articles kind of as afterthoughts about lifestyle and Mediterranean diet and such. Okay, so now will these surgeries work in terms of getting rid of something like type 2 diabetes and so forth? And the answer is, the more zippy the surgery, the more likely you can do that, and yes is the answer. So, you know, what's not to love there? Well, what's not to love is, you know, things like, gastrointestinal bleeding, dumping syndrome, hyperinsulinemia with hypoglycemia that's hard to deal with, straight up surgical complications. Now, like all procedures, the more people do them and the more innovation there is, the better they get. And they are getting better. But do you really think we can operate our way out of our obesity problem? I mean, it's going to have to get way safer, way cheaper, and so forth in order for that really to be our answer. Although for certain individuals, it is, I think, life-saving. Okay, so here's another one where you can take a piece of ileum and move it up into the area just below the stomach. That works. This one's kind of technically hard and is not done very often. And we have a lot of other invasive things. Endoscopically placed balloons in the stomach. You can have a hole in your stomach and just drain out what's in your stomach after you eat. That's been FDA approved. It's called the Aspire Assist. And so you eat, you wait a little bit, then you go in the bathroom and drain your stomach contents into the toilet and flush it away. Will you lose some weight? Yes. You can put in intestinal sleeves endoscopically. And basically that does this. It shunts your food past the upper small intestine and lets it hit the distal small intestine sooner. And that works. Okay, so now people noticed that you would get improvements in glucose tolerance before you had any significant weight loss after bariatric surgery. And that led to the realization that gut hormones were being changed by gastric surgery. And so people thought, okay, that's the scoop. And then some work was done using knockouts for the gut hormone receptors. And guess what? The surgery still worked. And so it looked like that wasn't the story. And so then you had to figure out, well, okay, then what is the story? And possibly it has to do with the fact that the surgery alters our gut bugs. That remains to be, proven. It is clear that our gut bugs are important. We just don't know enough about them to use them in a therapeutic way because we don't know how to manipulate them right. Unless Dr. Todd has the answer. And he says no. Okay. All right, so now we move on to what's old is new again. And here's Dr. George Cahill. And he was doing the presidential address on starvation at the Transactions of the American Clinical and Climatological Association, how timely, in 1983. And in that talk, he goes over the phases of starvation, which he was actually involved in defining in his experimental career. So he says, in transition from the fed to the fasted state, there is a sequence of metabolic alterations to provide calories for survival, listed as follows with their approximate duration. Gastrointestinal absorption, in other words, how long it takes the food to get from your stomach into your blood, and so he's saying like 8 hours. And then we have glycogenolysis. We're going to break down glycogen, and that's going to provide sugar for our blood and our brain and what have you. And then, within the first week, we are already doing gluconeogenesis. We're making glucose out of what? Out of glycerol from fat and out of amino acids. And before that week is over, we begin to do lipolysis and produce ketone bodies, beta-hydroxybutyrate in particular, and that begins in the first week. And then it gets more and more pronounced, so that over time we do less gluconeogenesis. Why would we do that? Well, we don't want to chew up all our protein, now do we? Okay. On the other hand, we usually have plenty of fat to work with. So here's Dr. Cahill again at a younger age. He had passed on in July 2012 when he was in his 80s. And here's a tribute to him by Dr. C. Ron Kahn, who was the Mary Iacocca Professor and Chief Officer at Joslin Diabetes Center. So, who remembers Lee Iacocca? Yeah, some of the older folks remember Lee. Yeah, he was a car executive. And there was diabetes in his family, and so he funded diabetes positions and research. So anyway, here's Dr. Cahill, and it says the major scientific question that interested him was human starvation, and a major issue was fuel for the brain. And in the early 60s, it was known that you needed 100 to 145 grams per day of glucose for the brain. So it got to come from somewhere. It was widely held the brain did not oxidize ketone bodies for energy. Ketones are unique as a metabolic fuel because their concentration can vary from virtually nothing after a meal that contains carbs to like 7 millimolar after 5 weeks of starvation. And he was one of the few clinical investigators to believe that during starvation there was not enough nitrogen in the urine to account for the amount of glucose that the brain was thought to need. In other words, the numbers didn't add up. You look at how much nitrogenous stuff is coming out in the urine, and you back calculate to how much protein you had to burn to, give that, and it wasn't enough to provide for that amount of glucose for the brain. So, therefore, had to be coming from someplace else. So he measured the AV difference of uptake over the brain and discovered, in fact, that ketones were being taken up by the brain, and they made up the difference. Yeah. Okay. So here's Dr. Kahn. As he looked when he was giving talks when I was younger at the Endocrine Society. And this is how he looked last year when I heard him speak at Obesity Week. And here he's got an article where he argues, along with Dr. Bray, that fructose is not so good for you and your liver. What he was talking about at Obesity Week was how they had discovered that the lab chow that were being fed to some of his special insulin-resistant rodents made a difference to what results you would get. So he discovered that the microbiome of his carefully constructed kidney insulin-resistant, muscle insulin-resistant, pancreas insulin-resistant, et cetera, animals gave you different results. And so what was he doing? They were going back and redoing their classic experiments to find how many times the results would differ. And the answer was all the damn time. Something that we need to know more about. So here's what goes on in starvation. Your fat releases fatty acids, goes in the blood to your liver. That gets oxidized. You get beta-hydroxybutyrate back into the blood, and then from the blood into neurons, where it can fuel your brain. So this is how we survive starvation and are still able to walk around and see if we can find some food. Now, here are some genuinely starved people from the famous Minnesota experiment during World War II run by Dr. Ansel Keys, where they really did starve them for about 6 months. And here they are at the end of the 6 months. These were conscientious objectors doing their bit for the war by starving. And you can see they're on a Minnesota hillside in the summer, catching a few passive sun rays to warm up because they're cold, and they're not moving around much because, well, they're pretty listless. And this is what happens when you overdo starvation. You get sick. These people had a 20% drop per kilogram in their VO2, which is their energy consumption, and that's per kilogram of lean mass, and it's 40% per man from their baseline. And this is over what period of time? Oh, 6 months. Okay, and here's another guy. This is me. And this is starting in January 11 through January 2017. And as I pointed out to you, I'd been on diets and yo-yoed up and down for 50 years. My previous lowest weight as an adult was about 141, and that was the one I showed you, that nadir, back in my 20s. My highest level was about 231 in February 2009, which was 2 years prior to the start of this graph. And my main program to lose this weight was a fairly low-carb, normal protein, not high protein, and low glycemic index vegetables program. So a kind of new Atkins variant. I also started journaling with MyFitnessPal, and here's the one I did over the weekend where it notes that I've done it every day for 4.5 years. You know, when you lose weight finally after 50 years, you want to hang on to that sumbitch, you know? So that's, I'm hanging on. One of these days, maybe I'll have the confidence to stop doing this, but it hadn't happened yet. So we'll see. Anyway, so I lost about 100 pounds overall, and that was down to a lower level than I've been since, I don't know, 6th grade, something like that. Okay, and here's me if you plot me on the surgery that I showed you before. So I lost 43% of my body weight. And the surgeons like to talk about how much of your excess weight you lost, because that does make the numbers bigger. It's of the amount of fat above your ideal body weight, how much did you lose? And the answer was, all of it, because that's where I am now. So it can be done. Of course, I'm an N of 1. On the other hand, I'm so typical in so many ways. Anyway, so now what's new? Promoting health and longevity through diet from model organisms to humans. And this is from Cell 2 years ago. They say reduced food intake, avoiding malnutrition, so you can't overdo it. They say can ameliorate aging and aging-related diseases in invertebrates, rodents, primates, and humans, and recent findings indicate that meal timing is crucial. So intermittent fasting and timing your feeding can in fact improve health and function. And then here's the kicker, in the absence of changes in overall intake, and also in the absence of like exercise programs. Lowered intake of particular nutrients may be important, rather than overall calories, and protein and amino acids may particularly be involved. And they point out that the biome probably is doing something, but who knows exactly. So here's dietary restriction will in fact improve health and lifespan in everything from yeast to worms to fruit flies to rats to, here's the yeast, here's rhesus monkeys, and then question mark humans. Now, if you're biologically inclined, if it works for rhesus, what are the odds? Pretty good, I think. So here's a table from that paper where they show you, do you change the maximum lifespan, do you change the mean lifespan by doing different things? And the answer with calorie restriction is yes, intermittent fasting is yes, protein restriction, mean yes, max no, and certain amino acids, yes. Endurance exercise, max lifespan, not so much, mean lifespan, yes. Is there a commonality between exercise and various kinds of nutrient restriction? And the answer is yes, there is. And then here are all these other genetic interventions, and can't go through them all, but they all tend to affect nutrient sensing pathways. Here are some pharmacological interventions. Rapamycin is a nice one, which specifically affects TOR, which is one of these nutrient sensors. Insulin is another one, and AMP-K is another one, and on we go. So here's a little diagram showing that between yeast and worms and flies and mice, we have some of these same key molecules. And this is just another way of saying this is an ancient and conserved set of molecular controls. Here's Dr. Osumi, who got the 2016 Nobel Prize for autophagy, which he called an intracellular recycling system. And here are some folks, Dr. Longo and Mattson. Dr. Longo's from USC, where he's at the Longevity Institute. Dr. Mattson is at the NIH. And they're talking about how fasting has clinical applications and what are the molecular mechanisms. And they talk about the fact that chronic fasting extends longevity and that it protects against all kinds of disease processes, and so that it has the potential to delay aging and prevent disease. And then here's an article called Time-Restricted Feeding for Prevention and Treatment of Cardiometabolic Disorders. This is by Dr. Panda, who's at the Salk Institute, and did a lot of fine work on molecular clocks in the suprachiasmatic nucleus and elsewhere, and his colleague Dr. Melkani from San Diego State. And so here's a paper, Resting Energy Expenditure in Short-Term Starvation is increased as a result of an increase in serum norepinephrine. So they took some people and fasted them in a CRC. It was very carefully done. And what did they observe? They did just a 4-day fast. Well, the fasting sugars went from 88, which is normal, down to a lower number, 63. Norepinephrine went up quite a bit. Epi, not so much. Insulin starts out at this level, which these are normal people, and it goes down. So we have less insulin around. Despite that, the sugars are down. So what does that mean? Okay. Fatty acids, on the other hand, go up quite a bit. Triacylglycerol goes up. Beta-hydroxybutyrate. Well, remember Dr. Yes, thank you. So from almost nothing, this is what? This is 0.01 millimolar, goes up to 4.7 millimolar. Now I can tell you that when I was on a low-carb diet, I was usually about 0.3 to 0.5 millimolar, so down more in this range. If I really, really did it, I could get it up to 4 or 5, but that was about it. And here's BUN. So initially the BUN is climbing, but then it starts to tail back down. And if you look here, this is urinary nitrogen production. And just as predicted by our first guy, you start burning your proteins during the first few days, but then you adapt and you start to burn fat and you start to burn less protein. And so you're protecting your proteins. Their weight went down, and here we see metabolic changes over 4 days. The weight's going down. This is kilograms now over 4 days. And guess what? The resting energy expenditure is going up. And oxygen consumption is going up. So short-term fasts actually are associated with increased zippiness, not decreased zippiness. There's a surprise. High caloric intake at breakfast versus dinner differentially affects weight loss in overweight and obese women, despite the fact that these were isocaloric diets. So the calories were the same, it's just the time of day was different. And this shows that indeed they end up losing more weight if you repeat this over time, even though the calories were the same. And here's fasting-mimicking diet promotes regeneration to reverse diabetes. And this is streptozotocin-treated mice who are given a fasting-mimicking diet. And here we have the what happens with streptozotocin-treated and the regular stuff. And then this is what happens if we have the fasting-mimicking diet plus streptozotocin. They make more what? Insulin in their islets. Well, gee. And since they're making more insulin in their islets, then they're having better glucose control. And here's a human study by Longo's group in which they gave a proprietary fasting-mimicking diet which had low calories, low sugar, and protein, but high in unsaturated fats. And they've got a patent on this stuff. And it also gives you improvements in all kinds of things that appear to be related to health, aging, and even cancer. So here's time-restricted feeding without reducing caloric intake. And this is from Dr. Panda's group. And so the difference here is whether the animals got exposed to food only part of the day versus all day long. The great animal model for diet-induced obesity is ad libitum exposure to a high-fat diet. It's called diet-induced obesity. That would be these guys, and they do get fat. You can give them the same amount of fatty food, and if you restrict the time interval during which they can have access to it, they stay lean and do much better. So, what's the summary here? The ability to adapt to a lack of food is a basic need of organisms, and you can do that by going dormant. If you can become a spore, or you can hibernate, or you can burn your stored energy, which would be lipolysis. The other thing you can do is you can, in a targeted way, consume the less valuable functional elements, as in cells and proteins. And we call this apoptosis, autophagy, and for mitochondria, mitophagy. And this is what Dr. Osumi got his Nobel Prize for, is the fact that this is a regulated process. And you will start by getting rid of the stuff that most can be expendable. And that'll be your first line of defense against this kind of stress. And across species, it's been observed that seasonal and circadian rhythms do correlate with food availability patterns. We grow and reproduce when there's plenty of resources, and we hunker down and survive when there's not. And it turns out that stressors like exercise and periodic short-term fasts will give you protective development of this type of metabolic adaptation. The molecular clocks in the hypothalamus, in fact, are coordinated with molecular clocks in virtually every tissue, and each tissue has its own regulatory things going on. Liver is using things like the availability of sugar and the availability of amino acids. And all of this stuff goes back to these key nutrient sensors. Early sensor is what happens to your insulin, but longer term is what happens to mTOR and AMPK and other things. And it may well be that our ancestral patterns of activity and energy intake are a better way to go than what we've been doing lately. So, fasting and time-restricted feeding are what we used to do quite a bit. They're old. They got lost the last half century. It's hard to make money promoting this. You're telling people don't eat, so you can't sell them food. Where's the profit? And people are very much afraid of fasting now. And if you're on the wards and you don't feed the patient for a day, the family's all over your case. They're starving, right? And yet, maybe there's a lot of potential here. So, barely on time.